Okay, we're looking at
So
data from Landers, telluric antenna station. And okay, go ahead, Art.
So this is the solar activity. The green is the Earth ionosphere waveguide, the noise level. The red is the underground telluric. No one would understand the names I use for it, but the signals underneath the ground, the earthquakes, what I call the earthquake signals. And the top is the vibration counter at Landers on the seismograph.
Okay. So what dates do we have here?
I forget what year, like 4 years ago, whenever the Haiti earthquake was.
Okay.
See, you can see the months are here.
Oh, gotcha.
Here.
Yep.
I've got to make sure to put page numbers on these before.
Gonna scroll down.
See how when the solar flux goes? These are earthquakes. See these vertical lines?
Yep.
Those are the major earthquakes of the planet. So this was Indonesia, Philippines, British Columbia, Mexico, North Mexico. This thing was something strange. So it must have been underneath the ground at Landers. This one was in Northern Cal. This was Eureka. This was Haiti. This was Mexico. This one doesn't have a name. This one doesn't have a name. This one doesn't have a name. This was Sumatra. In Mexico. Salton Sea. This is Mexico too. I did Baja. And then it was time, but the logs are lost now, so I can't.
Okay. I will go over this. Kind of seeing the correlation of solar flares and earthquake activity.
Yeah, well, look, I mean, obviously, you know, peaks and earthquakes.
So peaks.
There's solar surge and earthquake.
Solar surge.
See when there's no solar activity?
Yep.
No earthquakes.
What is the?
So see how the Earth's vibrations at Landers, how they correspond exactly to the increase in solar activity. And when the sun died down again, the vibration died down.
What did the?
Just like we had a recent increase in solar activity.
Yeah.
There's been a recent increase in earthquake activity.
So what did we find out with the telluric and the antenna system, the above ground and below ground? What did that?
Though there wasn't enough local earthquake activity to kick up the underground.
Okay.
So it's just basically you're looking at the ionosphere. You can see how the ionospheric noise went up here. That's what that's how I got the Japan earthquake. See, the ionospheric noise did a thing like this. So that one in Mexico. See, the green one was just for Los Angeles.
Okay, so green's underground?
The underground, yeah. And it was only a very narrow range. It was just for I didn't want long range.
Okay.
Because the green one, if the green one jumped up here, Los Angeles is going to get a 6.5 or greater earthquake.
Gotcha. All right.
The earth signals only occur at 6.5 or greater.
6.5 earthquake magnitude?
Yeah, about 6.5 or greater. That's when the ground starts to sing. So what the green is the singing. You'd have to hear it. It sings.
Okay.
But the red is the crackling.
Oh.
I had networks to distinguish between the two. The reason for that is, see how they tend to correlate together?
Yep.
Because the earth refracts. So this signal is the antithesis of this. So what you do is you subtract this from this to equalize it out, so you know exactly when this one starts to go after subtracted from this, you know there's going to be a big earthquake in the local area. You see what I'm getting at?
Yep.
Alexanderson had a name for that, called the barrage system, where you pick up the noise on one antenna and the signal on the other, and then you take the noise antenna signal and you turn it upside down and you put it into the signal you're trying to receive, and it cancels out the noise.
Very good.